Hey everyone, welcome to the next video in our series. Now, we talked a lot about quadratic equations and the idea of the null factor law in the previous video. And everything we did in that previous video, we are going to be applying to this two-part video today. Now, we're going to be solving different types of quadratic equations over this video and the next by factorizing. So, I'm just going to jump right in to some questions and we are going to discuss and recap some of the ideas we talked about in the previous video as well. So going into a couple of different types of quadratic equations, I'm going to give you one here. We have x squared plus 4x equals 0. Now, if you remember from the last video, the only way we were able to apply the null factor law is if our quadratic was reduced to some kind of product, because the null factor law told us that to get a product equaling 0, or in other words the solution to this equation here, one of our terms in the product has to be 0, and there are two cases, if A equals 0 or B equals 0. Now, in order to solve this then, we need to reduce our expression on the left-hand side into some kind of product, and we can do this by factorizing this. Now, our x squared plus 4x, we can see that both of these expressions have a common factor of x. So we can pull this out the front. And what we're left with when we factorize is, well, x goes into x squared x times, and x goes into positive 4x positive 4 times. And we have our next line of working. And now if you remember, when we actually multiply, when we have these terms outside brackets, we are actually doing a multiplication here. So that means we can apply our null factor law. So that means that we have two solutions for x. We talked about this in the last video. One of these solutions, when this expression is 0, as well as when this expression x plus 4 is 0. So we have two options, two solutions, I should say, to this equation. Now, one of these is when our first term in the product is 0. So one of these is when our first term x equals to 0. So this guy out here, because subbing in 0 back into my quadratic is going to give me 0 times 0 plus 4, but we already have our thing multiplying by 0 here. So we're automatically going to get this solution. That's what the null factor law is all about. So one of the cases is when x equals 0. That is one solution to the equation. There's one way to get this thing on the left-hand side equaling 0 on the right-hand side. Now another way is for this expression, x plus 4, to be 0. So we want a value of x that's going to make this thing, this expression x plus 4, be 0. And we can find that as a recap from the previous video by solving the equation for x. Now, subtracting 4 from both sides gives me x on its own on the left, and I get negative 4 on the right hand side. So I have two values of x, one being 0 and one being minus 4, that when we substitute these in, I'm going to get my left hand side equaling to 0 because of this null factor law. This idea that I'm always going to get a solution of 0 if my first term or my second term, my a or b, is equal to 0. Now in this case, my a is my x, my b is my x plus 4. So I'm pretty much just trying to find cases when each of these terms will be 0, and for what value of x those will be 0. Now the first one was kind of easy because x is on its own, so this is clearly going to be a value of 0, but for the next one we had to solve the equation in order to get a value of x equals -4 to make this term 0. And we can check that by substituting back in. -4 plus 4 gives me 0, and then 0 times -4 substituted back into the x is going to give me my right hand side of 0. So let's try another question here using the null factor law again. So I have an example, 2x squared equals 2ax, and now I want to first get this in the standard quadratic form. We talked about this in the previous video. So I want all of these guys, both of these guys on one side, equaling to 0 on the other side. Let's actually just change this to 10x to make it a bit different. Now, I want to get everything on one side. So the easiest way to do this would be to get my 10x over to the left-hand side. Now I can do this by manipulating the equation. So I want to bring this right-hand side to 0. I'm going to get that by subtracting 10x from 10x, and I'm going to do that to both sides here. So now on the left-hand side, I'm left with 2x squared minus 10x, and on my right-hand side, I'm going to get 0. So now we can try to solve this equation here. Now, we're going to do this once again by factorizing, right? All of these examples where we're trying to solve quadratic equations, they're going to require us to factorize first, because factorizing quadratics gives us these types of products with a factorized form. And we use those products to apply the null factor law. That's the most useful thing in helping us solve these equations. Okay, so here I can take out a common factor from both of these terms of 2x, because that goes into both of these terms here. And when I do that, I'm going to get that 2x goes into 2x squared x times. 2x goes into minus 10x minus 5 times. And my 0 on the right-hand side stays the same way. Okay, now once again, I have my product here on the left-hand side. I have a product of 2x and a product of x minus 5. So I want to figure out what are the two cases or the two values for x that are going to make this thing 0 and this thing 0 as well. So I'm going to lay out my two cases where 2x equals 0 or x minus 5 equals 0. So here, I want to find what number on the left here multiplies by 2 to give me 0. Well, we know that anytime we get 0 as an answer for a product, one of these has to be 0. So this x must then be 0. We can also get to the same way by solving the equation. Here we have 2 times x, because in algebra, writing 2x is a shorthand for 2 times x, or 2 lots of x. So we're going to do the opposite operation, divide both sides by 2, and on the left-hand side, that's going to undo this multiplication here, and I'm left with x on the left, and 0 divided by 2 is going to give me 0. So similar to the last example, one of my expressions in the product, I have a value of x equals 0 that makes 2x 0, and thus a solution to my quadratic equation. Now the other one here, I have x minus 5 equals 0, so I want to find the value of x that makes this equation true. I can do that by solving the equation. I'm going to, here we're subtracting by 5, so I'm going to do the opposite operation, and I'm adding 5 to both sides here. And I wind up with x on its own on the left-hand side, and 0 plus 5 gives me 5. So I've used the null factor law that we've been talking about extensively in the previous videos. I'm just trying to find values of x that make each of these expressions 0. Because if one of them's a 0, the product, them being times together, timesing by 0, always gives the answer of 0. Now, you can check these two values of x if you'd like. You can try, at home, to just substitute these back in to my equation on the left-hand side and see if you get 0. But if you have a go at that, you will notice that for both of these values of x, we have two solutions to the quadratic, two possible solutions. They're both going to give us x here. Okay, now, okay. We're going to try two more examples. We covered something similar to this in a previous video. It would have been year 8 equations, but we're going to revisit this again. We want to solve quadratic equations, which are a difference of two squares here. Because these are, difference of two squares are types of quadratic expressions. We looked at these. Now we want to solve these here. Now, what we can do when we don't have this x term here, when we don't have a coefficient of x, so for example this -10 here, we can solve these in a couple of ways. Now I'm going to run through both for this particular question, and it's up to you guys to decide what you like better. Now, one way I can do this is I can just solve the equation as I normally would. We talked about this in the video from year 8. So I can say that I want to get x squared on its own here. So what I'm going to do, let me actually write a heading. This is method 1. I'm going to add 16 to both sides, because that's going to leave me with x squared on its own here. So when I add 16 to both sides, I'm going to wind up with x squared equals to positive 16. And here I can just take the square root, because the square root of this side is going to undo the squaring and leave us with just x on its own. That's the essence of what we want to get back to when we solve these equations. So I'm going to take the square root of both sides here. Take the square root, take the square root. What do I get left with on the left? Well, I get x, and I'm actually going to get two solutions on the right hand side. I'm going to either get positive 4 or negative 4. So I'm going to write this with this plus or minus 4. Because remember, with squaring a number, that means multiplying it by itself. So if we multiply positive 4 by itself, 4 times 4 gives me 16. But also if we do negative 4 times negative 4, the double negative gives us a positive. So we wind up with 16 again. Okay, that's method 1. You can do it this way if you'd like. Now, because we're talking about factorizing here, I want to show you this method 2 through the lens of factorizing. Now, if I rewrite my question here, x squared minus 16 equals 0. This guy on the left is a difference of two squares, because x squared is a perfect square and 16 is also a perfect square. I get 4 multiplying by itself to give me 16. So we remember that to factorize a difference of two squares, I can express this as a binomial product with my square roots here of my first term, x squared, and the signs here and here are going to be different because that cancels out my x terms when I re-expand. If this is brand new to you, I've done a video on factorizing differences of two squares, so please refer to that. I'm recording this video assuming you understand how to factorize differences of two squares, so that's why we're rushing through it a little bit here. But I have here x plus 4 and x minus 4. That is how we factorize this into a binomial product. And because we have a product here, I can apply once again my null factor law. So I want two cases. I want to find two values of x which give me this first term being 0 in order to get me a product of 0, or this term being 0. Now, what does that mean? I want to find a value of x for which x plus 4 is going to equal 0. And similarly, I want to find a value of x for which x minus 4 gives me 0. And now I just solve the equations. So here I have x plus 4 equals 0. I want to undo this adding of 4 by subtracting 4 from both sides. And in the second example, I want to undo the minusing of 4 by adding 4 to both sides. Doing these operations will give me my x on its own in both of these cases. So on my left-hand side, I get 0 minus 4 gives me negative 4. And on my right-hand side, I get 0 plus 4 gives me a value of x equals positive 4. Or in other words, x equals, if we want to write this in a shorthand way, mathematicians are lazy, we like to write these shortcuts, this can be written as x equals positive or negative 4, which is the same solution we got up here. There are two ways for you to do it. You can choose whichever way you would like. So, the final question for today, I'm going to do this, it's another difference of two squares. I want to do this by factorizing. Now you can do it using method 1, which I showed you, but I'm going to do this using method 2 by the factorizing the difference of two square method. Now, I get for this example 3x squared minus 18 equals 0. So you may notice here I have one perfect square here, but 18 isn't a perfect square. So if I wanted to, I can factorize out my 3 here. Now that may not help us, but just for ease sake, I'm going to take this 3 out. And I'm left with x squared minus 6 equals 0. Okay. So this doesn't really help us out too much. I can also kill this 3 if I'd like. Here I have 3 multiplied by x squared minus 6. I can just divide both sides by 3 to get rid of that 3 altogether, because dividing it on the left-hand side is going to kill this guy out the front here, leaving me with x squared minus 6, and 0 divided by 3 gives me 0. Okay, now this is, I maybe haven't done this in the best way. Method 2 may not be suitable for this particular question, but it's not impossible if we understand surds, which we've covered in this previous video. Now we can reduce any difference of two squares by finding a number that multiplies by itself to give me 6. So now if we take the square root of both of these to end up factorizing this, taking the square root of x squared gives me x and x. Taking the square root of 6 here, now this isn't a perfect square, but I can still factorize it because I know a number that multiplies by itself to give me 6. And that one is going to be root 6. And I'm going to leave it as a surd because if I don't, it's going to give me an irrational number. So I'm going to pop my plus and minus here because I factorize this difference of two squares. And now I can apply, because this is a product, this is a binomial product, I can apply my null factor law. So I have my x plus root 6 equals 0. I want a value for x that makes this expression equal to 0, so we can apply a null factor law. And I also want a value of x that makes this expression 0, so I can once again apply the null factor law. And from here, we're just solving the equation. Now, because we've already looked at surds in a previous series, we can still solve equations using surds. Because all we want to do is we still just want x on its own. So we can subtract root 6 from both sides here. In the same way, we can add root 6 to both sides here. And I get x on its own on the left and minus root 6 on the right. 0 minus root 6 gives me minus root 6. And x is on its own on the left here once again. And that equals to 0 plus root 6 gives me positive root 6. So my x I can write as being plus or minus root 6. Kind of made it harder for myself using this particular method. Once you start dealing with surds where you don't have a perfect square, sometimes it's not wise to try to do a difference of two squares with these types of surds, but it still works. But another way you could have done it is you could have done it by method 1, which was putting the 18 on the right hand side and just solving the equation. Or once you get to this step, just adding 6 to both sides to get x squared on its own, and that would give you 6 on the right hand side. Taking the square root of that would give you plus or minus root 6. So if you'd like for extra practice, you can try method 1 at home to solve this particular quadratic equation from question 4. But that is all for today. We have dealt with two different types of quadratic equations that we can come across in this course, and we will look at some more in the next video. But thank you so much for joining me, and I'll see you there.